Welcome to the SPE podcast, powered by the Society of Petroleum Engineers. You're listening to SPE Live, Advanced Membrane Technology Applications for Produced Water Treatment. The audio from this episode was previously recorded on December 11th, 2024.
Welcome to this SPE Live, Advanced Membrane Technology Applications for Produced Water Treatment. My name is Patricia Carreras. I am the General Director at Blue Moon Strategies, and I will be your moderator today. Today's SPE Live will last 30 minutes. We encourage you to ask questions in the chat during the program. It is now my pleasure to introduce our guests. Peter Christou worked for the Canadian Armed Forces as a water and fuel environmental engineer. After the military, he became a troubleshooting and commissioning specialist working at some of the most remote locations on Earth. Peter started Swirltex in 2016 in his garage and now has completed projects in Antarctica. Swirltex has also built North America's largest produced water membrane treatment system and Canada's largest food and beverage membrane treatment system. Swirltex has used its patented buoyancy-enhanced membrane filtration process in numerous industries and is recognized as the largest increase in tubular per membrane performance in history. Dr. Jinwen Wang is a Vice President of Product at PSP US, where he oversees the development and commercialization of the company's PolyCera membrane technologies. His work focuses on driving product innovation, expanding the product portfolio, and supporting global business development. Previously, Dr. Wang served as Director of Product Development at PolyCera, playing a pivotal role in the company's early technological advancements. Before joining PolyCera, he was Product Manager and Lead Membrane Scientist at Water Planet, where he led the research and commercialization of PolyCera's membrane technology. In 2010, Dr. Wang contributed to the Deepwater Horizon oil speed cleanup as part of the University of California, Los Angeles, UCLA, technical consulting team. He obtained his master and PhD degrees in civil and environmental engineering from UCLA. Peter and Jinwen, welcome to this SPE Live.
All right, thank you for having us.
It's a pleasure to be here.
Thank you so much. Well, let's start with the questions. I would like to ask you, what is the biggest challenge for produced water treatment given tightening regulations? Jinwen, perhaps if you can start.
Sure. First, it's really my pleasure to be here to discuss membrane technologies in produced water treatment. So go back to Patricia's question, what's the biggest challenging for produced water treatment? In my opinion, meeting discharge or reuse standards while managing reasonable cost is the biggest challenge. Now the produced water is largely for recycled on-site or disposed to surface pond or injection wells. So that requires fairly simple treatment so the cost is manageable, especially given the current oil price. But if the regulation becomes tighter and the requirement for reuse, especially beneficial reuse out of the oil field increases, that means more advanced treatment technology is needed, for example, the membrane technology, and the cost may be an issue. So the cost I'm talking about here is not just the capital investment for the system, the equipment, and also the operational cost, especially for the energy required to run the treatment process, and also the chemical is needed for the produced water treatment.
Thank you. Peter, can you add anything about regulations?
Yeah, I think probably one of the biggest challenges is the mindset sometimes we have within the industry that it's just a lot easier to dispose of the water, pump it down the hole, than set up the infrastructure that's needed to recycle that water properly. I think as the restrictions around water reuse or water access to fresh water get tighter and tighter, it'll force more companies to employ technologies that recycle that water and make sure that the water quality is of reuse, especially for pumping it back down the hole or refracking, etc. With the tighter regulations, the access to water really dictates drilling programs, which has a financial aspect to it as well. And I think the higher the financials pay off for water reuse, the faster it's going to happen within the industry as well.
I see. Yes, I think that we are all aware of sustainability and its effect in our industry. So thank you so much for that answer. What specific applications of membrane technology are currently being used in the oil and gas industry? Peter, can you expand on that?
Yeah, we use ultrafiltration in a midstream application in produced water to make sure that the water quality is of reuse quality when they can get consistency and don't have to spend millions of dollars maintaining the water in the ponds. There's an added financial advantage to that. It's a poor choice if you store, 50,000 barrels of water, and then 3 months later, when you try to use it, the water quality is degraded so much you can't use it. So making sure that water quality is of reuse quality or sustaining that water quality is the primary use that we have with our membranes in the industry.
Jinwen, any addition to that?
Yeah, so the Peter summarized is for the produced water treatment, of course, using like ultrafiltration, like what we are working at the PolyCera, and also some like other like nanofiltration, reverse osmosis for produced water treatment, especially for reuse purpose. Since Patricia, you're asking for more general like oil and gas industry. So in addition to produced water treatment, membrane technology also being used for like a gas separation. For example, to remove like a water vapor from the natural gas to prevent corrosion and hydrate formation, and also to separate some acidic gas, for example, carbon dioxide or hydrogen sulfide from methane in natural gas. And also membrane can be used for like a downstream refinery and petrochemical industry for like their like wastewater treatment, and also for example, like hydrogen recovery, or separate some special like aromatic compounds using like a pro-vibration type of membrane technology.
Thank you. What are the most used type of membranes in the oil and gas industry, and how their properties affect performance in harsh environments? And if you can both provide examples in areas of the world where these have been used, I think that will be interesting. So type of membranes. Jinwen, can you please?
Yeah, sure. Yeah. So I think I will speak more from the membrane material aspect for the like type of the membranes. I think Peter can add on the process or like other aspect of the types of the membranes. So currently there, in terms on the membrane material aspect, there are 3 types membrane are used. One is the organic polymeric membranes, for example, like a polysulfone, polyether sulfone, polyamide, polyimide, or polyethylene membranes. So those membrane made from those materials are relatively at a lower cost, but it also has a lower thermal or chemical resistance compared to other materials. And they are prone to oil falling and prone to degradation in highly acidic or basic or solvent-rich environment, which is fairly common in oil and gas sector. Another type of the membrane in terms of different material is inorganic ceramic membranes. For example, they are made of alumina, silicon carbide, or titanium dioxide. Those membrane made of inorganic ceramic materials are at a relatively higher cost compared to polymeric membranes, but they have high resistance to temperature, to chemicals, and mechanical stress. And also, they normally have a longer lifespan, and usually it can, some of the manufacturers, they're advertising the ceramic membrane lifetime can be 10 years to even like 20 years. And they have ability to handle abrasive streams, which are also common to see in oil and gas sector. And they have a better fouling resistance compared to like polymeric membranes. The third type of the membrane used for oil and gas sector, we call it the hybrid membrane, which is combining the property of components of both polymeric and ceramic materials. For example, there are like a metal organic framework membranes and also organic metal membranes. We are working at PolyCera. So those membranes, they combine the flexibility and the economics of polymeric membranes and also the durability and the resistance of the ceramic membranes. They really show like high fouling resistance and chemical tolerance and have improved performance and economics in oil and gas sector compared with polymeric and ceramic membranes.
Thank you so much for that very detailed answer. Peter, any additional comments related to the type of membranes and how the properties can affect performance in harsh environments?
Yeah, unfortunately, membranes haven't really taken off in the oil and gas industry as they have in water and wastewater treatment. One of the main problems in oil and gas is oil. When oil interacts with the membrane, it can stain the membrane. It's kind of like getting oil on your clothes. Water can't get through it. And that fouling action can ruin operations. So that's really kind of led to selective uses of the membranes or a lot of pre-treatment in front of it. Membranes now are definitely, or the industry is really trying to solve that issue, especially with the oil. But the main membrane that I see being used, or the configuration of the membrane that I see used in the oil and gas industry right now, is probably reverse osmosis, just especially for removing the total dissolved solids, the salts out of the water, so that water can be reused in select applications. In some formations, the TDS is too high for reverse osmosis. In those cases, then membranes are just used to clean the water as high as possible so it can be re-injected on the next frac.
Thank you so much, Peter, for your vision. I would like to ask Peter, continuing with you, what are the main challenges associated with using membrane technology in our industry, the oil and gas industry?
It's going to be mainly about the integration. Oil and gas is different from water treatment, but it's not really. When you're setting up plants for these treatment facilities, there's a special engineering that you use to kind of set everything up, and it needs to be a combination of the understanding of what's kind of going on in the oil and gas, and the understanding of around like the equalization space you'll need for the flow rates, etc. And getting those conversations started to do things properly are sometimes very difficult, right? And they're very costly. And showing that business case where it's nice, rosy, saying, okay, this is the money you can save if you do this. It needs to be extremely bulletproof to be able to get somebody to commit to doing that. The other ways of kind of moving industry forward or moving membranes forward within the industry is different types of contracts, whether or not capital contracts, where almost midstream applications where you're paying on a usage for that water, or almost central hubs for different areas where you can send your flow back water, your produced water, and then get your next frac water back. We really have to find different ways of introducing technology into the industry that de-risk it for the clients as well.
Thank you. Thank you, Peter. Jinwen, do you have any additional comments about challenges?
Yeah, I think Peter talking about on the high level and the business, how to make a business case for using membrane technology in our oil and gas industry. So I maybe just add some from a more technical perspective. What's the challenging when actually using membrane in the oil and gas industry? Like I think Peter mentioned on the last question, he mentioned the falling is the biggest, oil, especially oil in the produced water cause membrane falling. That's definitely is the biggest challenging with especially conventional membrane technology. And the other one is chemical and thermal stability, because for produced water, especially right now with the fracking fallback, there's a lot of chemicals like polymers, fracking chemicals inside those, along with those water. So those chemicals also can cause falling and the performance degradation issue for membranes. And also it's a thermal stability requirement for the membrane material. And some of the produced water is a very high temperature. And Peter mentioned reverse osmosis membranes. So also the high salinity, some is very high salinity, and the TDS, total dissolved solids level, it can be 5 to 10 times of seawater level. So that's a required problem, like high pressure requirement for the reverse osmosis will increase the energy cost. And another challenging for using membrane technology for the technical perspective is how to managing the concentrated brine, because the membrane will concentrate the oil or the salt, and those brine, those stream, how to properly dispose or properly manage to manage those stream is another challenging on the technical perspective.
Thank you, Jinwen. How can membrane longevity be improved in the presence of corrosive or extreme temperature fluids, which are very common in our industry? I will appreciate, Jinwen, if you can elaborate on that.
Yeah, so it is, I guess those questions are really interconnected. So we talk about the challenging, and Patricia just mentioned the corrosive or extreme temperature. It is a challenge for a membrane. For membrane technology, especially affect the longevity. So in my opinion, there's a 3 aspects we can do to overcome those challenges. Number one is, of course, is start from membrane selection. So as I mentioned earlier, there's the 3 different type of membrane material, and the ceramic membrane material and the hybrid membrane material. For example, organic metal membrane, better to have better chemical and thermal resistance to handle those corrosive and high temperature environmental settings. And also for process design, for membrane treatment, there also pre-treatment for membrane process is also very important. So to design a membrane process, you also need to pay attention to the pre-treatment to make sure the membrane not taking all the loads and all the stress is on the membrane only. And also for system design, that's a good thing for membranes. It can be designed as a modular design. So which means if one part of the membrane of the whole system needs to be serviced, and the whole system don't have to be shutting down, it still can have the uptime for running. The third part is the operation optimization. For example, for this corrosive and extreme temperature settings, they're always kind to adjust the pH or adjust the temperature to make sure the membrane system can run to its specs and not have too much stress. And also the membrane system require regular maintenance, like cleaning, to make sure the falling and the scaling not become irreversible.
Thank you, Jinwen. Peter, any comments about longevity? How long do they last?
Yeah, I think it really comes down to picking the right tool for the job. If you have an application that's high temperature and has corrosive properties, you're really going to want to pick a membrane that can handle that. that would probably be a ceramic or a ceramic-based membrane that was designed to handle high temperatures and corrosive environments. If you're using a polymeric membrane, it's probably not going to be a good choice, especially for these types of environments.
Thank you. Peter, if you can please answer these questions. How do membranes compare to traditional methods like air flotation and adsorption in terms of energy efficiency and cost effectiveness?
It really depends on the overall application with membranes. I know from our side of it, the biggest difference is the consistency. Everything has changed to membranes for drinking water and wastewater because the consistency of the effluent. Membranes provide a physical barrier where solids can't get past. What I've seen in the past, especially with the air flotation, is you can really try hard to get your water quality to where it needs to be and store it, and then they have a shift change and somebody else is operating the DAF, and all of a sudden you have an upset and your reservoir is now full of solids again. And that's a hard process, and in any treatment process that you can have upsets like that. But when your DAF is the final step before it kind of goes up to your pond, it's kind of you're not going to see your cost recovery from the DAF operations. So comparing membranes to traditional technologies, it really comes down to that consistency. I think they've definitely come down in cost to the point where they can be cost competitive, especially for the water quality that they produce and the lack of operator input or manpower in order to make them work properly.
Thank you, Peter. Jinwen, any comments about the comparison with other methodologies?
Yeah, for the comparison membrane with a traditional technology, for example, like absorption or like dissolved air flotation DAF, I guess it's mainly depends on settings. If it's for just a reuse or beneficial reuse, then the membrane, as Peter said, is provide absolute barrier to prevent like solids and oil pass to ensure the consistency in the treated water quality. That's the biggest benefit for using membrane compared with traditional technologies. And also in terms of the cost effectiveness, the initial capital investment for membrane technology right now is maybe a little bit higher than traditional technologies, but we have to look at the long term and combine operational cost and those initial capital cost. And overall, the membrane can provide the most versatile and the most comprehensive treatment, and also it's a multi-barrier state. It can remove both, for example, ultrafiltration, remove both suspended solids and oil from the water, and with a consistent output, the quality for the consistent treated water. So I think I have to look at the treated, the treatment effectiveness and the long-term operational cost to compare membrane technology versus conventional treatment options.
Thank you, Jinwen. So I would like to remind our audience to please ask your questions. This is a very short event, and I am going to ask now the last question to our two speakers. How do membrane technologies contribute to reducing the environmental footprint of oil and gas operations? Peter, can you provide some comments about that?
Yeah, really by facilitating water reuse. Water reuse in the industry doesn't have a good reputation because so many failed projects. And that probably goes the same with membranes too within the industry. But for the projects that have been working, you can clearly see the cost reduction, and not just the cost reduction, but it really kind of changes their perspective. When you can budget around having a certain water quality, when you know that you don't have to do biocides and dredging your ponds due to solids buildup, or the saving cost of pigging lines, that really needs to be looked at as the overall kind of cost effectiveness of the technology. So companies can look at it not just from the environmental side, and it's great that we're recycling water, but also the cost savings around having clean water and that effects on the rest of the infrastructure that clean water is running through as well.
Thank you, Peter. Thank you so much. I will now go to the questions from our audience. We have a question from Rodelio Romero. He is from Philippines, and he's asking, what is the best membrane for oil removal? If you can elaborate on that. So, Jinwen, if you want to start.
Yeah.
Sorry, Peter.
Okay. Yeah, sure. So first, thank you for the question from Philippines. And the best membrane for oil removal, so first you have to have a membrane can tolerant oil. As we discussed earlier, you maybe need to look at like a ceramic membrane or hybrid membrane, like a organic metal membrane to remove for the oil removals. So the minimize the falling of oil on the membrane. That's what we talking about more like a free oil or emulsified oil. But there are also like a dissolved oil. For dissolved oil, you may have to look into like a nanofiltration or like a reverse osmosis for like a dissolved oil removal.
Excellent. Peter?
Well, there's two different doctrines within the industry. The first doctrine is to try to make the membrane out of different materials that will reject the oil to reduce fouling. And the second doctrine is trying to use hydraulics to make sure that the oil doesn't interact with the membrane nearly at the same rates. Both have their advantages to them, and it depends exactly where you want, at what stage in the process, and what concentration of oil you're going to have within the water to decide which route you're going to take as far as using a membrane to remove oil from the water.
Excellent. I will ask another question from the audience. Is for the membrane design, are we talking about a series of membranes or a single membrane? Peter, if you would like to answer that question.
Usually they're in a series. So for instance, for our systems, in a membrane train, we have 4 banks of membranes, and the water will flow through 8 membrane modules in a series in each bank. So for our applications, they are all in a series.
Thank you. Jinwen, any other comments related to this?
Yeah, so I guess it's all depend on what's the goal to what's the goal with the target to remove for removal. For example, like if we talk about produced water, so if you're talking about just particulates or the free and emulsified oil removal, then a single membrane type can be used. Like ultrafiltration is good enough to achieve the goal. But if you want to also remove the salt, like the dissolved solids or dissolved hydrocarbons, you would need a series of membranes like ultrafiltration followed by maybe nanofiltration or reverse osmosis to achieve the total removal goals.
Thank you. We are reaching the end of this event. I would like to give Peter and Jinwen an opportunity to wrap up if you wish, to say any comments. Very briefly, Peter, any comments?
Well, thank you for hosting this event. It was my first SPE Talk Live, and look forward to the next one.
Thank you so much. Jinwen.
Yeah. Also, it's a pleasure, honor to be here and talk to you, Patricia, and talk to Peter, and also thank you, the SPE staff for organizing this wonderful event.
Thank you for the questions and comments and for joining us today. See you next time.
Thanks for listening to the SPE Live podcast. For more content, visit the SPE Energy Stream, the industry's digital pulse, at streaming.spe.org. If you enjoyed today's show, don't forget to subscribe and review. Join us next time on the SPE Live podcast.